I look forward to seeing you in person somewhere in Australia at some stage soon as well. Thank you very much for coming today. This paper is very much work in progress. Looking forward to comments, and both co-authors are also on the call as well. This is a joint piece of research with Tong Xiang from Beijing Institute of Technology and also Qi Wang from Sichuan University. And I know on the call there's a lot of China expertise. Yanrui, I'm looking at you, and also others. So please, I'm very much all ears for feedback and from learning from you during the seminar today. This topic is about China's electric vehicle sector. Why electric vehicles? Well, this is one of the key technologies for decarbonizing the road transport sector. That's about 1/10 of China's greenhouse gas emissions, and that is a growing share as well. EVs are an important part of the story, but only just one part of the story, but a very key one too, as we move towards a low emission economy. China is in the fast lane when it comes to electric vehicles, and adoption has been much quicker so far than in Australia, although this year in Australia, uptake is starting to increase quite impressively as well. As of 2020, if you're talking about electric cars, well, almost half, 44% anyway, of the stock of electric cars was just in one country, China, 44% in China in 2020. And uptake has been growing quite quickly. So this graph here is the stock of electric cars rather than purchases of new ones. Rest of the world, well, China has a disproportionate share in the overall global stock of electric cars. Uptake has been quite quick and impressive, and the Chinese government has been serious about it and has been introducing quite a few policies to try to speed up adoption of electric vehicles. In this seminar, what we're going to do is we're going to do an econometric analysis which includes some of these policy measures. In particular, the focus is on a key policy measure, which has been subsidies, purchase subsidies for electric vehicles. However, we're also controlling for some other policies introduced in China as well to try to make sure we are capturing other things going on. A bit of background. In China, one of the very key incentive policies to encourage EV adoption has been purchase subsidies. It's just a subsidy that we all know from our teaching of Micro 1. It's a subsidy that you get for the transaction, and you'd expect that the incidence of the subsidy would be shared between the final consumer and the seller of the electric vehicle as well, or the supply side of that transaction. A key point is that subsidies have been made available nationally. Also, some cities and provinces themselves have introduced supplementary subsidies that scale up the national subsidy. And we're going to be using that geographical variation as one of the dimensions of variation in this study. The subsidy rate has actually varied three-dimensionally, and we're going to be using a three-dimensional data set in our study. The subsidy rate has varied by model, city, and over time there has been variation as well. Why by city? Well, there has been variation because cities and provinces have introduced their own supplementary subsidies. Why by model? Well, because the subsidy has been, per vehicle subsidy has been higher for vehicles that can drive further. And in short, for better electric vehicles, you have a higher per vehicle subsidy. So there's been variation by model as well in the per vehicle subsidy rate. This is looking not at the stock, but at annual sales of electric vehicles in China, 2011 until 2020. When talking about electric vehicles, well, it's kind of like talking about some other technologies like rooftop solar. They basically were not in the market 10 years ago. basically. The numbers were so small. And this is something that has really come along over the last decade. So in China, the EV market share of new vehicle sales was over 5% in 2020. Australia last year was at 2%. So Australia was back at this sort of level, but this year in Australia, EV sales are really jumping up, and we might even be up to something like 5% this year. Let's wait and see for the rest of the year to play out. Anyway, let's get back to China. The key thing here is that the numbers have been going up quite quickly, and off nothing back in 2011. This graph also splits them out into BEV, this is battery electric vehicle, and also plug-in hybrid electric vehicle. There's also another type of electric vehicle, which is the fuel cell electric vehicle. That means you use hydrogen and you have a fuel cell in there which generates electricity. This yellow one is very, very small, and we actually exclude it from our analysis. It's a very small and marginal technology, and probably isn't going to go so far relative to battery electric vehicles in the long run, if we're talking about the passenger vehicle market. This map is showing the average purchase subsidy per vehicle, and this is by city, and it's for the year 2018. We don't need to take in all of the information in this map, but the key thing is there has been variation in the average per vehicle subsidy when we look across China. So some areas have had a higher average subsidy per vehicle than others. One of the reasons for that is that, as mentioned, cities and provinces in some cases have offered their own supplementary or top-up type of subsidies. We're going to be using that variation in our analysis. So what are
Paul?
Yeah, please.
Back to that picture. I mean, how the subsidy, compared to the price of the car, how much percent it is?
Yeah, that would be better. You have a percentage share.
Yeah, so we don't, in our regressions, we don't use the percent of the price, and we don't actually have vehicle price data that we're using in the regressions. It would be possible to do some work to collect that, but we don't have the vehicle price data for all of these models. The percentage of the subsidy in the subsidy inclusive price for vehicles, well, it does vary. As you can see, there's variation here, but it goes from something quite low to above 20% of the purchase price. I don't have that exact number here or a map showing that number either. Ken, I see your hand is up also.
This map, are all of these provinces equally important in the EV market?
No, some of, and first thing to mention here is this map is actually by city. And one interesting thing in China, it's a bit different to Australia in that the city also involves the rural area around the city. So if you're drawing a map of cities like this one, then it's shading in all of the area in this section, right? So it's by city rather than province. And the importance, the number of people and the number of vehicle sales, it does differ a lot. So Shanghai and Beijing are large and some other places much smaller.
So the larger cities are going to be more heavily weighted in what we're going to see?
What we are estimating is our average effects, and we don't use city importance weightings in it. It's something that we could do. That's right. We could use some weightings related to the number of vehicle sales in a city. That's true.
That would serve to make it more representative.
Yeah. One thing we do that's related to that point is that we exclude small cities in one of the estimations, and we focus in on the 19 largest cities. And in general, the results are quite similar. So that's related to the point that the results aren't just driven by only the small cities. Yeah.
So Paul, I'm just saying there's quite a few areas where you have no data. Is that going to be an issue in terms of sample selection, or what's the story there where there's no data for those areas?
A key thing is that our sample will be excluding Tibet and Xinjiang autonomous regions for data reasons. That's the no data that takes up quite a bit of this area. Apart from that, we have very broad coverage of cities. We've got more than 300 Chinese cities, and the great majority of electric vehicle sales are in the cities in our data set. More than it's close to 100. It's like 98% or something like that, because in short, in Tibet and Xinjiang, there aren't so many EV sales.
Thank you.
So our questions are, how large has the effect of EV purchase subsidies been on EV adoption? We're interested in a marginal effect. We would expect to see that higher purchase subsidies should lead to more adoption, and that's what we do see. One thing that I haven't mentioned yet is one of the interesting features of the policy. The purchase subsidies have only been for domestically produced electric vehicles. Imported electric vehicles from overseas have not been able to benefit from the subsidy. So you'd expect this policy to be encouraging uptake of domestically produced EVs and distorting or reducing uptake of the imported EVs. And that's what we do find in our analysis, and we quantify those effects.
Paul, just a quick question. So when you say this, if Tesla were to produce, cars in China, would they be subsidized?
Yes, if the company sets up an office and is producing in China, they would be subsidized. Yeah,
I see.
But in the early days, Tesla wasn't doing that, and so Teslas were counted as imported vehicles and not subject to this beneficial policy for them for vehicle sales. Second question is, we do something which has been done in some studies, for example, of North America, and that is we use our regression estimates, and then we ask another question. What is the subsidy cost of reducing CO2 emissions via an increase in the per vehicle subsidy? What we're interested in is this an expensive or cheap way of abating CO2? We do a calculation that involves quite a few steps. I'm going to outline it in my presentation today, but it's in the paper. It's very similar to one that in my earlier research on Australia's rooftop solar program, we actually did the same type of calculation looking at the subsidy cost of abating CO2 via a hypothetical shock to the per vehicle subsidy. That's what we'll be doing in this study as well. It's not the overall marginal cost, it's the subsidy spending cost of the public sector in China for reducing CO2 emissions via a shock to the per vehicle subsidy rate. So just a little bit more about the paper and its contribution. So it's the first EV adoption study in China to use a three-dimensional national data set. So we use a data set which has three dimensions. One is vehicle range class or group. So we don't actually use a model data set because models do come and go quite frequently. And we don't use a brand or company data set. We actually collapse the EV registrations to the range distance. And I'll talk a bit more about that coming up. The other dimensions are month and city. We also do an estimation. Instead of month, we use quarters. But our main specification is a 3D, three-dimensional panel. We also do a 2D panel estimate as well, and results tend to be quite similar. This study is the first to analyze the subsidy cost effectiveness of EV subsidies on CO2 emissions in China, using a similar approach to a couple of other papers that have looked at North America, Canada, for example. We look at separate effects on imported EVs and domestic EVs, which is kind of interesting. We also look at the effects of some other control variables as well. In some cases, we can notice some effects, and in other cases, it doesn't look like much is happening in terms of the estimated effects. So the data set. We have a data set that is, first of all, by month. And we have data, we're using data for 4 years, 2016 to 2019. And we're not going into the COVID early 2020 period there. We bin the models by electric driving distance or range. So for example, your electric vehicle, you might be able to go 300 kilometers by battery power alone. Well, that 300 kilometers, that's within one certain range type. And then we construct 8 of those range types. So the key reason for doing this and binning by range is that the subsidies themselves have also varied by range. So that's one key reason why we did that. Also by city, we have 324. Yeah, Simon, over to you.
Hi, Paul. Thank you. I wonder, do you have any information on the supply side? Because your major goal is to estimate the subsidy effect, and I assume that's shifting the demand curve. But the effect will be identified if you can hold the supply fixed. If the supply also shift in the same time, then or maybe it's in your way, you're thinking about more general equipment, or you're thinking about this subsidy on consumer may also have impact on the supply, and then you don't care, you just want to have the net effect.
We are thinking that effects on the supply side, well, a producer in one location, it can then sell its vehicles across the country. And often that's the case, that the supply of a particular brand is quite broad, and it's not just constrained to the individual city. So we totally think that there could be some other interesting studies focused very much on the supply side and looking at questions like, have there been some weird distortions as a result of this policy? For example, bunching just above a subsidy range, EV range distance threshold, that type of thing. But in short, in our study, we don't look at supply side issues, and we essentially assume that anything's happening on the supply side would have common effects across the cities on the demand in the final marketplace. Yeah, does that make sense, Simon?
Yes, but it's thinking about from the dynamics. So, because my impression is that there are more and more companies join the market. So that if you, since you're looking data across time, and then if there's a dynamic expansion in terms of the supply, I think that would have an impact on your outcomes.
We control for some time dummies to try and take into account some general things that are going on.
Right.
And by doing that, what we're trying to do is isolate the variation that is relevant across our 3-dimensional panel data set. So we try and control for some dummies and things like that to reduce those stories.
Sure, fair enough. Thank you.
Leandro,
I have a problem. Leandro?
Thanks, Paul. This subsidy, it's totally independent of the type of the car, if it's a luxury or not luxury, SUV, or it's totally orthogonal. It's just based on the distance, on the driving range.
To my understanding, it's based on the driving range, and it's not based on the price or whether it's categorized as a luxury vehicle. Yeah.
So, for example, SUV would have the same subsidy as a simple drive car.
If the range of the two types
Yes.
of vehicle is the same, I believe that to be the case. Yeah.
Yeah. But I mean, I would
It's based
suppose,
on
the
range.
SUV, the range would not be as bigger as a simple car because of the weight of the car. So, okay, so I will expect, I will wait your regression results to see if you have control for this or not.
Hi, Paul, can I supplement something?
Yeah, sure, Tom, please do.
Yeah, so previously, the subsidy is not depending on the price. But after the year 2020, the vehicle with the price higher than 300,000 Chinese yuan will not enjoy any subsidy, but that data is not included in our sample because it is after 2020. Yeah.
Tom, you're brilliant. Thank you. That's very useful. Thanks, Tom. And please do jump in anytime. Ishita, over to you as well.
Hi, Paul. I had a quick question, which is that you are using subsidies to check whether there is an increase in the uptake of the electric vehicles. But do you also look for other factors that facilitate the uptakes, such as rollout of charging stations, battery walls, and things like that? Because there would be some cities that would have a much developed system of electric car charging along the drive.
The answer is yes, but imperfectly. So we do control for some other policies, but we don't have data on the density of charging infrastructure. If we can work out where to get it from, we might be able to control for that. But as you'll see, we control for quite a few policies, but yeah, definitely not everything.
Okay.
And we are looking to improve that as well. Okay, let me just go through the data set here. I've mentioned some of these points already. Only passenger cars are included, so we're not looking at buses and trucks. I mentioned that the hydrogen vehicles are not included. And this is where key thing with this study really is putting together the data set, and the registration data is from this research institute shown on the slide. A key thing in doing econometrics is thinking, how do these how do these variables vary? Are they varying, first of all, is it quite exogenous or endogenous, but also in which dimensionality are they varying? First of all, in China, there is a central subsidy provided by China's central government. This one varies by driving range and month. And as Tom said, in 2020, there's a bit of a change to that, but in our data set by driving range and month. Also, local cities or provinces, in some cases, have introduced subsidy. Really, we can think about them as subsidy scale-ups. And these are proportional scale-ups of the central subsidy. Quite relevant for our identification strategy is this final point here. In mid-2019, the central government decided to cancel the subsidies from the local cities and provinces. So these subsidy scale-ups had been in place across the country, and then from above were cancelled rather abruptly, not overnight, but rather abruptly by the central government. We treat this and we use this as an instrument in our estimation. We're not saying it's a perfect instrument, but it's a good chance for us to check the robustness of our estimates using this approach. And I'll talk more about that coming up. Here is our model. The key thing to be understanding the model is we have a 3-dimensional data set by range class, by city, and by month in the main estimation. The dependent variable is new domestic EV registrations. Although later on, we also do regressions for imported EV registrations and then total EV registrations as well. So number of registrations in the range class, city, and month is the left-hand side. The key explanatory variable is the real purchase subsidy per vehicle in 1,000 Chinese yuan. And this one also ranges or varies 3-dimensionally by range class, city, and month. We then have quite a few controls, especially other incentive policies, and I'll be listing them very shortly. Not everything, and we'd like to include at least a couple more controls, so happy to hear any ideas as well. We then include some time style fixed effects, month of year fixed effects, and also year fixed effects. And we play around with some different ways of doing that. We have range fixed effects, and we also have city fixed effects in our main estimations. Estimation approaches, we go for linear regression. We go for OLS to start with. And then well, it's a fixed effect panel regression, but just a linear one. Negative binomial, and I'll talk more about that when interpreting the table. And also, as mentioned, we go for an instrumental variable regression as well. We also do a few other things in the paper. For example, we do a 2D panel estimation by city and month. So that gets rid of the range story from the analysis by collapsing it and just looking at a two-dimensional data set. We also have a look at an estimation using quarterly data in which we control for some other economic type of variables, which are typically measured quarterly rather than monthly. Yeah. All right, so other incentives. Here's a list of other variables that we control for. So we do control for some things like in some cities, electric vehicles enjoy reduced or waived parking fees. So in that case, we control for it using a dummy. That variable is measured using a dummy variable for cities that provide that benefit. Different cities do go for different approaches to incentivize EVs. I want to focus in a bit on the very bottom one here, the NEV credits, and just briefly explain what this is. Recently, China has introduced an alternative approach, which is like a baseline and credit scheme. For manufacturers that are producing electric vehicles, they can obtain credits under what's called a dual credit policy. And the maximum number of credits for a vehicle is 5. On the other side of the market, if you're producing gasoline-powered vehicles, well, you are having negative credits, and then you have to buy credits or trade them internally with companies that are producing clean vehicles. So this is a baseline and credit scheme, and we do control for that. This one only varies by range and month and not by city. Yanrui, please.
Yeah, Paul, I wonder whether you have information about the location of the manufacturers, say having local government protections in mind. Basically, I say if in my city I have a local producer, probably want to protect my local manufacturer. Maybe the subsidies are targeted protection instead of encouraging purchase in general.
We don't. Even those local cities, they go for policies like the ones on the slide here. Yeah. Well, that would be picked up in the regressions. Tong, I see you're unmuted. Do you want to jump in as well?
Yeah, actually, I would like to control for this policy previously, but I saw the regulation that Chinese government has a regulation that to avoid localism protection in EV market. So I'm not sure if to control for it, Paul.
Yeah. So we've partially, we might have quite well controlled for it, we're not quite sure, but via the variables on this slide. So if the local area is trying to promote EV adoption via some of the measures here, then it's been controlled for in the regression.
Or you can simply have a dummy variable with the city has a local manufacturer or not, versus cities without. And also, just for information, now the subsidies per vehicle, is it applied to all cars? It's kind of the same standard, or actually vary according to different cars?
It varies by how far the vehicle can drive. So the range that it can drive. So if the vehicle can drive 500 kilometers on battery power, it will get a larger subsidy.
Yeah, that's why I have this in mind. Say I could have the type of a car produced locally. Probably my subsidy or heavily targeted this type of car in order to promote local job market and manufacturing.
Well, that's true. Just one other thing here is that we do control for city fixed effects as well. So it's only if those things change over time, over the 4 years of the study, that we'd need to worry about having some other type of dummy as well. Yeah.
Okay. Thanks.
Yes,
All right,
so can I just cut in about I had the same concern as Henry, but I think the map, when I saw the map, I think that concern I don't have that concern anymore. And it's striking to me actually, the subsidy rate is higher in some Western provinces, and even some cities which is not the capital city of the province. It is a bit striking to me. I used to think maybe, as Henry said, so because of the local protectionism, it could be some main producer provinces or cities, but it seems to be not that case.
Some cities might want to produce vehicles, but then sell them outside the city, right? Also relevant to that, Sean, is that maybe in the West, people have a preference for driving further. And it's an important point to note that the average per vehicle subsidy is a function of vehicle choices of consumers. So if people are going for the longer range ones in the West, for example, then that would help to explain that variation partly, probably.
That interesting point. Yeah.
Simon, please.
Thanks, Paul. So I wonder, is it's possible that these local government subsidies might actually be related to their local air pollution level? Because down the road, you want to examine the effect on pollution as well, right? So is it possible, because since like Sean mentioned, like the Western provinces tend to have higher subsidies, and it is also my impression that, for example, Gansu was a province that has a very terrible air pollution. Is it possible that the local government respond to this air pollution level by raising the subsidy so that to encourage, people switch to EV and then in order to reduce the air pollution?
It's possible.
Yes.
So partly we've controlled for those things through a city fixed effect, but that's only partly. Yeah. We also use an IV strategy because exactly for the points being raised here, we're worried that the average per vehicle EV subsidy is a function of choices of consumers and the cities and producers as well.
Yeah.
So we want to try to bring in an instrument, and we do seek to do that.
Right. Thanks. Yeah.
So potential endogeneity is a concern. Potential reverse causality, because the average per vehicle subsidy is a function of choices. And also there could be other emitted variables. In a study like this, it is impossible to fully control for everything. One can do a better job than others, that's for sure, but it's impossible to bring everything into a regression in a well-measured way. We use an IV approach. What we do is we instrument the key explanatory variable, the average per vehicle domestic EV purchase subsidy, with a binary variable. So it's kind of like a DID estimation approach. The instrument equals 1 from July 29 onwards in cities that previously had local subsidies and 0 otherwise. Remember, the key context is China's central government removed the local subsidies abruptly and across the country as of mid-2019. So what we do is we use this as a kind of policy experiment. It's not really a natural experiment, a policy experiment. And the key thing is that decision, it affects cities in different ways. And also, just to mention before I go over to the questions, our instrument varies 2-dimensionally. So it only switches over to 1 in cities that initially had the local subsidies. And before July 2019, it was 0 for all cities. Girish, please.
Thanks, Paul. So this is very interesting. What I wanted to understand, I have no knowledge of the federal structure in China. So I'm just wanting to get clarity here. Before this policy change happened, was it possible that the central subsidy coming from the central government was somehow a function of what local subsidies you get, or was it completely independent of the subsidies at the local level? You see my point?
It was a central one, so it was there first, and it was independent of the localities, and then the localities did their own things on top of that.
I see. Okay.
So Paul, can I just ask, I mean, why wouldn't this instrument be exogenous? So why, I mean, using it as sort of a secondary specification. So I'm just wondering why, I mean, I don't know the context that well either. So, I mean, why wouldn't this policy change be considered exogenous and therefore a valid instrument?
Good question. Yeah, I've been a little bit modest about or cautious about the instrument. The key reason, Michael, is that the initial decision of the local areas to have subsidies in the first place actually affects the variation of this instrument. Here's one of those seminars where the authors just tell you everything. So that's the very key thing, is that, okay, so the central decision might have been rather exogenous, but the initial decisions of the localities to have the subsidies wasn't so exogenous, and that does play into this instrument and how it's working. So we think it's not bad, but actually, like quite a few instruments, it's not perfection. And a good thing with using IV is it's a good check that the single equation results are quite robust as well.
But don't you already control for a year and the month fixed effect?
We do a couple of different things, but in the regression that I showed earlier, we control for year fixed effect and month of year. Month of year is just seasonality only, 11
Yeah,
dummies.
but if you combine the two, you actually capture this, right? Because this is just before and after July 2019.
It's a good question, but that's not right, because this one also varies. This one varies two-dimensionally. For cities that never had a local subsidy, it remains zero throughout. So it's not only temporal variation, it's actually different for different cities depending on
okay, got it. Okay,
yeah.
Yep.
Leandro.
Paul, do you have information about the price of the petrol along the times for at city level?
In our quarterly estimations, we do control for the price of gasoline.
Okay, that's fine.
In general, this price varies temporarily in a very similar way, city to city, based on law of one price. And generally, it moves very similarly.
So there's no variation across cities? Is the same
across
price?
Cities, there would be some persistent variation, but in general, not super interesting variation.
Okay.
So it's not like Venezuela to Norway, where the price is totally different. Within China, the price would be relatively similar across different areas at one time, with some variation, but not. My point is,
because prices is something that could control for pollution as well. Anyway, okay.
And Tushar, do you want to jump in?
Hi, Paul. I'm mindful of the time, so I'll try and keep it short. So the way you have constructed the instrument, obviously the impact of this policy change would differ by what the pre-existing subsidies were from the local government, right? So there's a distance in terms of where they're coming from. And that pre-existing subsidy is also going to affect the adoption of EV vehicles in the past. So the change in EV vehicles over time could directly be affected by the measurement error that you have in your first stage, right? So your first stage is the subsidy regressed on an indicator variable 1, 0. But the indicator variable has a lot more information, right? So in fact, what you wanted to do was basically take, measure how much of a reduction in subsidy there has been, right?
The indicator variable has less information, right? Because it's just 0 or 1.
Yeah. So the rest of the information goes into your measurement error now in the first stage. And that measurement error is correlated with the outcome in the second stage as well.
I would say that it's advantageous to have a 0, 1, because at least the 1 is not itself varying in terms of its scale with the size of the subsidies.
Yeah.
So at least it's collapsing that bit out. So it's either 0 or 1. So I think it's a nice way to reduce the size of that issue and to just have a more simple variable that's just the shock from the center.
Okay, yeah, sure.
Let me jump into some tables. There are plenty in the paper, and I know everyone has a copy of the paper. So let me just briefly summarize some of the results. This one is a linear regression. And what we find is this coefficient, and it's positive and significant, which is what one would expect. This is the dependent variable is domestic EV registrations. What we mean is domestically produced EV registrations as written here. So positive, this one here is a negative binomial estimation. The coefficient here is the effect on the logged variable. So the way to interpret this, make sure not just to compare this coefficient and this one, apart from the sign and significance, but the magnitude has a different interpretation. This one means a 1,000 Chinese yen increase in this variable would lead to about a 6.8% increase in the dependent variable. Yeah. Some of the controls are shown here as well. So for example, I mentioned that NEV credits variable as well, which is a two-dimensional variable. We get positive coefficients for that in various regressions, not always significant, as you can see here. The odd other variable is sometimes positive and significant. There's another subsidy, which is a vehicle replacement subsidy per vehicle. We've measured it here as per vehicle. We get a positive result for that one too. But our focus is this main big policy, which is the purchase subsidy policy of the centre and local areas as well. Data set is quite big, and remember it's a 3D data set, which does tend to make things bigger. There are 8 range classes in that dimension, the R dimension. Just briefly, I'll just interpret this coefficient here. What it means is that a 1,000 Chinese yuan increase in the purchase subsidy per vehicle would lead to about a 0.3 increase in vehicles being registered in the range class, city, and month. Sounds quite small, but if you multiply it out, so there are 8 range classes, 12 months in a year, lots and lots of cities, you can start to get quite a big number if you multiply out the effect across the country. This regression here is the IV estimation, and as we were expecting, the first stage coefficient on the instrument is negative. The removal of the local subsidies reduced the average per vehicle purchase subsidy. It's a very strong instrument, and we were kind of expecting that to be the case as well. Very strong passes a week IV test. The result in the IV specification, it's positive and significant again, and a bit bigger. It's 3 times as big as the single equation estimation. Quarterly estimations. This one here is actually showing for 19 large cities. We've recently expanded this estimation out to all of the cities, but for the moment, this table is showing for the 19 largest cities in the sample. So it's a smaller sample size because it's now 2D and only the largest cities. What do we find? And this is a negative binomial estimation. We find that the purchase subsidy for EVs in the range, class, city, and quarter is positively associated with registrations of domestic EVs, negatively associated with imported EV registrations, and that the net effect is positive and about 1%. A little bit lower than 1% here, but we do a variety of estimations. It's about 1%, this number. In the paper, we also do some heterogeneity analysis. In short, what do we find? We find a larger marginal proportional effect in cities with higher consumer awareness of the EV subsidies. How do we measure that? We create a couple of indicators based on scraping data from an online vehicle discussion forum, based on the number of comments related to subsidies in each province. And we construct 2 indicators, and then we interact that with the subsidy variable in our regressions. So please check out the paper for more on that. Also in smaller cities, we find a marginal proportional effect, which is larger. I just want to give a top level overview of our next step, which is following the similar logic path of a number of other papers that do a similar type of thing for different settings, in terms of technology or country. What we want to do is we want to ask the question, imagine that China were to increase the subsidy by, well, let's just imagine 1,000 Chinese yen. This is a policy experiment. We should expect that that would lead to lower emissions. What's your expectation? It should lead to lower emissions, right? But it's also a complicated calculation that would involve many assumptions. That's what we found. There are many steps in our calculations, as in the paper. In short, what we do is we say, okay, let's apply our estimates. First of all, let's calculate the future emissions from the additional purchased EVs. What are those emissions? Well, these EVs in China are using electricity from the grid. China's grid is very dirty, lots and lots of coal. So there are going to be additional emissions there. In the long run, if that grid is decarbonized, well, that's a different story. But for the moment, additional emissions. But, you know, there are emission savings because in the counterfactual, quite a few of those vehicles would have been gasoline vehicles, presumably. So we save those emissions. Then what we do is we calculate how many additional vehicles would have been registered. We calculate out the subsidy spending that would have been required under this scenario, and then we divide. What we end up finding is that the subsidy cost per ton CO2 abated comes out to be quite big according to our calculations, about $71 US. But please note a caveat that there's a confidence interval around that is not able to be precisely estimated because there are many assumptions along the way there. But in general, if we do a few things, in general, we get quite a large subsidy cost per ton CO2 abated. As an economist, it might be possible to look at that and think, okay, well, it's a pretty expensive way of reducing CO2. Well, probably so far that has been true, but it's a broader context than that. There are benefits other than CO2 reductions, and colleagues have mentioned it already. A key benefit is likely to be reduced local air pollution. That's not CO2, it's a different thing that we haven't calculated. Also, really a key reason for China to be going for these subsidies is more an industry policy one to try and become the world's biggest producer of EVs. If that's a benefit, well, it's totally separate to what's being represented by this number. In conclusion, just going through a few things and then looking forward to some questions. We find a net effect of a 1,000 Chinese yen per vehicle increase in subsidy to be about a 1% increase in EV registrations. We have more domestic and fewer imported EVs. We find that the subsidy cost per ton CO2 abated seems to be quite high so far. You could more cost effectively reduce emissions via other mechanisms such as a carbon price. And China has recently launched its national ETS, which is relevant to note. However, as mentioned, there are broader benefits of this type of scheme, probably some other costs to mention as well. My point is that this is not the only number that one would need to be considering. I'm going to wrap up just a very final sort of broadening out of the topic. China has announced that it would be seeking to move to carbon neutrality over coming decades, which is a major change to its economy. This was announced in 2020 and is a very important announcement in the context of climate mitigation. China is planning, now that the market is maturing in terms of EVs, to phase out purchase subsidies, actually to get rid of them for urban areas, but to keep them for people registering in rural locations as of next year. Other policies like the NEV credits policy are likely to become increasingly important in the policy suite. Just also to mention, we're focused on China, but some other countries like Indonesia have explicit goals to be ramping up production and also use of electric vehicles. So the various experiences from a place like China are relevant for informing what to do and what not to do in other countries. Looking forward to comments and thank you very much.
Okay, thank you. Thank you very much, Paul. I think we already have 3 audience. Okay, right, 4 now raising hands. I think it is Leandro first.
Thank you, Sean. Paul, can you hear me?
Very well. Yes.
Okay, Paul, my question is the following. So, do you have the, I see that your dependent variable is basically the new registrations of electrical vehicles. Do you also have information about the petrol, new registrations of petrol vehicles, and how this difference is changing over time?
So your thought is that it would be a good idea to do another regression with registrations of new gasoline
net
vehicles.
registration, because I would like to know how fast this subsidy is changing the impact this market.
So far, we haven't done that and we haven't collected the data, but I think it's a good idea. We could do it at the city month level. Range is not relevant.
And this also is going to be good for computing the final number. If you can get an idea about how this, if you see how this is changing over time, this would sharp your last.
That's true. And currently we assume in our calculation that if you buy an EV, well, you're displacing a gasoline vehicle, but we could check that using the method you've proposed. Thank you, Leandro. I agree. We haven't done it, and I think it's a really good idea.
Next, Ishita.
Thank you, Sean. I'm a little bit confused about the unit of savings, which is $71 US per tons of carbon emission. Is that annual number? That is annually.
The unit is per ton CO2.
Right.
And the way it's calculated is that we need to assume how long the EV will be on the road.
Yeah.
And that's 14.5 years is the number that we use. And then we have to look at lifetime future emissions.
Okay.
And then lots of calculations, but it comes back to a unit of per ton CO2.
Right. Okay. That was my question. Thank you.
Thank you very much, Ishita.
Ray.
Thanks, Sean. Thank you very much, Paul, for a very interesting presentation and very interesting findings too. Now, as you point out rightly, China is going to phase out subsidies. Actually, it was announced last year. So that means subsidies play the role, but it doesn't last for long. Now, from the policy perspective, I wonder whether you can shed some light on kind of say, as the what's the right word? At a different phase of EV ownership and development in the cities, and subsidies may have a different impact. So you could send a stronger message to governments, to countries where there's no subsidy, and if they are going to introduce subsidy, you may be able to find a very significant, dramatic impact at the beginning, but over time, it's going to be the impact is going to disappear or fall as the critical mass of EV ownership increases.
Right. So the point is that
clear.
Well, the point is the marginal effect might change over time, including it might fall over time.
Yeah.
We could test that. We can test that by interacting with a time trend. I don't think we've done that. Whether we would expect it to fall over time, I don't have a strong hypothesis that it would, but I think it would be useful to test it out. As the market certainly has matured quite a lot since 2016, so I think it would be a good idea.
And that also may answer the question Sean raised during the presentation. He observed actually the subsidies are pretty high in some relatively less developed Western regions in China. My suspicion is that the market there is pretty much at the early stage of development relative to the affluent coastal regions in China.
Yes, I think it's a good point. And in general, that's very true, that the support tends to come when the market is very nascent and small and then gets phased out. And China's doing that at the national level itself. Yeah, it's a good point. Thank you, Yanrui.
Yeah, following the point of Yanrui, the West regions, I think another point I can think of could be the electricity price there. I don't know. Yeah, maybe you can have a look. Yeah.
The electricity price is higher or lower?
Lower, because for example, the southwest region. So it just because a lot of the hydraulic power dams there, and usually so the electricity price is low. Yeah.
Okay. We'll look into it. Thank you.
Yeah. So Ken.
Yes, Paul. I'd be thinking about this as a new product. This new product starts off at 2016, really small. Initially, it's growing fast. The take-up is fast. Then you'd think that it reaches an inflection point, growth rate falls, and it asymptotes to some sort of upper ceiling level. So I'd be thinking about what is the stock of EVs doing here. See, the stock of EVs, I'd think, would be driving the current sales of EVs. So you get a sort of a growth path, a low growth path, or something along those lines, with the interactions between current sales, which is what you've got, and then the integral of current sales, which is the stock of EVs. So I'd be thinking about the dynamics of this over your 48 months, because things are changing fast. There's fast growth in China at that time. So there's fast pickup of EVs, compounding the fact that it's a new product and it's got these subsidies on it all. So another thing related to that, in your demand curve, I'd be adding income of the city too. I know you've got city effects and that sort of stuff, but the income is going to vary within the city over time. And finally, on your demand curve, I'm not sure that the linear demand curve or the semi-log demand curve really is going to be the best that you could do. I'd be thinking about, because with linear, that marginal effect is constant, as you were saying, and with semi-log, for 1,000 increase in yen, in UN subsidy, you get the same percentage increase in sales, no matter what the existing subsidy is. So I think you'd probably do better with log on that subsidy too.
Thank you, Ken. A very good set of comments. Log on the subsidy. In some cases, the subsidy is naught or very low.
Yeah, you have one plus the subsidy.
Yeah, it would be possible to do that. We could certainly try having a look at what happens if we log that and getting an elasticity. We currently don't have that. We have a semi-elasticity type of things. So we could try doing that. That's right. We've avoided it for that zero reason, but there are ways around that, as you've just mentioned. In terms of the adoption curve, the logistic or S type of curve, yeah, it's still in the very early phase. I think in the long run, we're going to get up to 100% of vehicles being electric vehicles. So we're still in a very early phase where, as of 2020, it was 5% of new registrations were electric. So it's still quite a minority early phase technology, although things have changed a lot since 2016.
But it varies across cities, though. That percentage of sales.
I think one thing for sure is that the derivative will have more variation than the stock. So the sales numbers are key margin that I think it's quite good to be examining the effect on the sales rather than on the stock.
Oh, sure. No argument.
Your point is that it can vary across cities. So we could control for the existing stock in each city. We could do that, couldn't we? Would that address the idea, Ken?
Yeah. You just add up the previous sales in that city. Assume that the EVs don't drive from one city to another.
I wonder the coefficient of that variable, the existing stock. If it's positive, that would be an explosive type of process, and if it's negative, that means that larger existing stocks, the uptake rate is slower, right, Ken?
Whichever way makes it exciting for you.
All right, I think we'll give it a go. We'll try. We'll have a think about this idea, controlling for the existing stock in the city.
If I can jump in quickly, Paul, on this 5% you mentioned, I think that in recent years, more rural bias of vehicles. So basically, the urban consumers buy EVs, and then rural area, because they live in the countryside, they probably dominated by the traditional vehicles. So if you have separate number, you may find a higher percentage in the truly urban areas of EV ownership.
Yeah, maybe. I think it would be interesting to have a look at rural areas. And I know China's government is turning its attention to encouraging uptake in rural areas.
Yeah, true. I think nowadays many rural areas, many old people, they just drive this EV. Okay. Because it's
rural
cheap.
Area.
Yeah, in rural area. Yeah, that's what I found. Yeah.
I'm somewhat surprised because in general, EVs are a city technology so far because of the range issue and maybe the price issue too. But yeah, so I think that uptake, Tom, feel free to come in. I think that uptake so far has been bigger in the cities.
Yeah,
EVs are sort of for zipping around a city rather than for in the countryside so far.
Yeah, but Sean actually is right, because in rural areas, especially for old people, they like EVs. Yeah.
Yeah, because it's very easy to drive, and also it's very convenient. They can just charge at home and drive to the field and to not very far place. So it's very easy for them to do so. Yeah.
And the most important reason is it is cheaper than traditional vehicles.
Yeah.
Be good to, maybe we can find some data at some stage to learn more about it.
Yeah. So next question, Amy.
Yes, hi. If I understood correctly, so you're regressing the number of new vehicle registrations in a given city on the subsidies that are on that same city. So my question is, how easy is for a consumer to arbitrage and cross the river and buy the vehicle on a different city with a higher subsidy?
That's a good question. My understanding is that you need to register it to a local address. And so if you're registering it to a local address across the country or in a different city, that you wouldn't be eligible for the subsidy from that city. However, I know that whenever there are subsidy schemes, there are always some ways to do some clever things. Tonga, do you want to mention anything here? It's related to where you have to register your local address when doing the purchase. Is that correct?
Yes, it's correct.
So in theory, that might not be much of a problem, but in practice, well, I'm sure there might be a few interesting things going on.
Is the subsidy paid to the consumer or to the dealer?
The dealer reduces the price from the listed retail price.
I see.
Yeah.
So, Tusha.
Yeah, Paul, quickly, a couple of minor points. They're both related to what Leandro was saying earlier. So I was wondering if, like, it seemed like your assumption was that these cars are replacing existing gasoline cars. And if they are not, then your calculation should take into account probably the amount of congestion that these cars are adding. to the traffic. And if that's the case, if these cars are not replacing but adding to the traffic on the roads, then I'm also worried about the exclusion restrictions to some extent, because now that you have less subsidy for electric vehicles, there'll be fewer of those. So the relative price of gasoline vehicles have come down, right? So the substitution effect will say buy more gasoline vehicles and less electric vehicles. So that's the IV channel that you're looking at. But there's also congestion that you have to think of now. So less gasoline, a greater number of gasoline vehicles on the road will also add to the congestion, which will change my benefit from owning an electric vehicle now. So there is another mechanism that is through congestion that will also affect the adoption of electric vehicles. So it's more like a general equilibrium analysis where you have both these markets that you're analyzing together. But so it might be useful to do what Leandro was suggesting, to look at how the number of petrol cars are changing.
Thank you very much, Tushar. And certainly I agree it would be useful for us to get those data and to check the effects directly on gasoline vehicle registration sales. Your comments seem mostly relevant for the cost calculation that we do after the regressions, because specifically in there, we make one of our many assumptions we have to make to pump out that cost number is that there's one-to-one substitutability against the counterfactual in terms of EV to gasoline. The key question is that correct or not? In terms of our IV in the regressions, I think it's not going to be much of a problem.
So let me try and communicate it better this time. So what I'm thinking is the channel that you are looking at for your IV is subsidies decrease, right? So there's a substitution effect that tells you buy less of electric vehicles, and the same substitution effect says buy more of gasoline vehicles now, right? So that's the channel you're looking at. But if I'm buying less or more of electric vehicles, what's happening is the congestion on the roads are also changing. So my benefit from getting into any of these kind of cars is changing. Right. So in my utility function, there is a weight that I put on assigned to the benefits from traveling in a car. That will also change. Or let's say the cost of traveling the same distance will also change because of the number of vehicles on the road now.
Well, that's an interesting idea.
Yeah.
The question is,
I see I'm pushing it too far. So
that could be part of the main channel itself, rather than being some omitted type of channel. In that, if the subsidy suddenly is lower, well, there are many factors in consumers' minds, and the one you're talking about might just be one of those considerations.
Congestion, yeah.
So I tend to see it as internal to the story that we're estimating, rather than as causing bias or something like that.
Oh, actually, I can help you out here. I used to live in Beijing 6 years. So, if it happened in Beijing, it's more likely that it's replacing the existing car, because it's very difficult to get a new license plate in Beijing. They've done it by lottery plate.
Okay, so to sell the existing car, right?
Yes.
So it still stays in the market.
Yeah, one plate for one car. So you can't have two cars for one plate in general. If you compare the effect in Beijing to other places where the license plate policy is more relaxed, you can easily get a second plate. Then compare the results between Beijing and other places. Because of the license plate policy are different, it affects how difficult you get a second plate. And that will affect whether you should get a new car and get rid of your old car and buy a new car, or it's related to how their concerns whether you're adding more cars on the street or you are replacing the old cars. Does that make sense?
Yeah, it makes some sense, Simon. I think it would be difficult to observe big differences just due to that. And the key thing is it doesn't matter what happens at the household level. It's the overall stock of vehicles that's important. So if I get rid of my gasoline vehicle and sell it to someone else, well, they're going to drive it and it would remain in the stock, right, Simon?
No, maybe they completely just go into the graveyard of the cars.
Well, maybe.
No, yeah.
In general, we don't send it to the graveyard if we could sell it, right?
I know, yeah.
Keep thinking about it. When I went to Beijing for a very brief visit, I actually went in my first electric vehicle. So I saw there are lots there, aren't there?
Because I never got a car in Beijing because I just never had a luck to get a lottery, to win a lottery. Yeah.
Well, certainly that would affect the overall uptake rate and overall new sales numbers.
Yeah.
We control for city fixed effects, so that maybe reduces that level effect that's persistent.
So Ishita still has a question.
Yeah, thank you, Sean. And my question is kind of a bit rambling, because I've been thinking in terms of the substitution effects, as pretty much everybody has been thinking. One thought was that you are seeing a remarkable change on two sides of 2019. But after 2019, so a large part of 2020, 2021 went into the COVID lockdown restriction. So there has been a lot of reports that because of the COVID lockdown, there has been less number of cars plying on the road. And as a result, the pollution level went down. I'm still not very organized in my thought, but the second point is that because of COVID, because people were working from home, lockdowns were happening in different cities at different time points, at different levels. People were probably not taking public transport and trying to do independent commute wherever they had to do wherever they actually had to do commute, because I don't want to get infected. So that could increase the probability of your buying a car even in cases like Beijing, where you are restricted to buying a second car, then you would definitely try to go for an electric vehicle where the license restriction is removed. My third point was that I'm trying to remember. Right. So in cities, from whatever little I have seen of China, in the cities, not the broader capital region of cities, we see a lot of e-bikes. So people who have to do this multiple modes of commute, and because they're living in a shorter distance or denser cities, they might not need to buy any vehicles or electric vehicles when this kind of new vehicle demand comes in. So instead of buying a passenger vehicle defined as cars, they may be actually buying e-bikes. And this kind of lastly ties me to Yanrui's point that he was trying to say that it depends on how much you actually need to travel. So those people who are living in a city and buying locally produced, domestically produced car in that city or in that region, they may actually not need to travel too much, and they may be buying shorter range cars. Whereas people who are living in rural areas, the point of location of work versus the point of location of their residence, they may be further apart, and they may actually need to buy a longer range car. So you might be able to separate out which kind of people are buying which kind of cars, looking at what they were buying, that is the base price of the cars in those kind of cities, before and after the electric vehicle came in. So if I was a person buying a $20,000 gasoline car, am I the person trying to buy a 20,000 electric vehicle, or I'm saying, oh, let's splurge, and if I'm buying an electric vehicle, now I'm going to go for a 50,000 all-range car. So you might be able to bring in some variation there.
Thanks, Ishita. We don't have data on who's buying the vehicles.
No, but you might get some the city level aggregate to see what is the pattern of buying in this city. And that's where Ken's point of stock is coming in, because you might be influenced by people around you. I don't have anybody living near me that I know who has an electric vehicle, so nobody is influencing my mind. But if you are surrounded by your colleagues who all drive EVs, then you might think, oh, that's the way to go. And so the stock effect might push you towards buying an electric vehicle of a higher range when otherwise you may not have been. So that's the catching up to what people are doing.
Yeah.
The Joneses.
Well, certainly there are many other things that are important, many determinants of uptake. And it's true, like for solar PV in Australia, there are contagion effects. If your neighbours tend to have panels, well, you get the idea as well. I think there are lots of opportunities for more studies, more papers here. And our study, it only goes until the end of 2019. So those recent COVID stories aren't in there. But just one more thing is that due to a reduction in EV sales and concerns about that, China actually had been planning to get rid of the subsidy earlier on. But when COVID hit, they extended the subsidy. That was after our study in terms of the data set, but that's interesting that they did that. Yeah, thank you.
Yeah. Okay, thanks, Paul. I think we have to end officially here now. But if you still have any questions or comments, you can stay here and raise your question, and we can have a further discussion.
Thank you very much for all of the comments and questions, everyone.
Thank you, Paul.
Yeah.
Thank you for having me.
Paul.
Thank you, Yanru.
Yeah, thanks, Paul.
Thanks, Ken.
Thank you, Paul.
All right. Thank you, thank you, everyone.
Yep.
Thank you, Simon.
Yep.
Sean. Thanks, Ishita.
Yep.
Yeah.
Paul,
Okay.
I was thinking some more about this rate of adoption and relating it to the stock. You, as an alternative, you might be able to set it up as an ECM, whereby the long run is